This presentation covers a DIS 2021 paper, Guiding Preferred Driving Style Using Voice in Autonomous Vehicles, an on-road Wizard of Oz study by Keunwoo Kim, Minjung Park, and Youn-kyung Lim. Everyone has their own preferences in driving. In the era of autonomous vehicles, it is important to match the AV's driving style with the user's preference for satisfying AV user experience. The user's preference in driving is multifaceted. While comfort in driving, such as maximum turn speed and braking distance, take a major part, how the vehicle behaves in social road take another important part. These preferences should be comprehensively reflected in the AV's driving. To reflect the driving preferences, researchers and corporations try to adapt AV's driving style from how users drive. However, mimicking the user's driving is not enough. Users tend to overestimate their driving's defensiveness and safety. So if the AV drives as users do, they could get scared or unsatisfied. Thus, the true value of AV driving style customization is not fulfilled when it learns how the users drive, but is fulfilled when it learns how the users actually want to be driven. As the user demonstration study shows, it's difficult for the intelligent system to learn how users would want to be driven. Then what if the users can take part in the adaptive system and share what they want in driving? It would allow users to express their multifaceted driving needs and change their state from passive passengers to riders who are in control of the learning cycle. However, there still lacks a proper channel for users to express their driving style needs to control the AV. Without such a channel, user experience in AVs is likely to be controlled by machine-oriented learning, resulting in a less fitted driving style. We suggest the concept of the user's preferred driving style guidance as a novel input channel for user needs. Our study goal is to explore how driving style guidance could be conducted in a realistic AV context, and to figure out possible benefits and hindrances in the user-driven guiding interaction. We used an on-road Wizard of Oz method to study AV user experience in a fully autonomous driving situation. There were two wizards, a researcher as an interaction wizard for voice interaction, and drivers as driving wizards for operating the vehicle. We used voice interface to let users guide their preferences. The diagram on the left describes the guiding interaction flow. When the passenger guides driving styles to the system, the interaction wizard gives voice feedback using text-to-speech application, and the driving wizard drives the vehicle, reflecting the passenger's guides. You can find the example of actual guide dialogue on the right. Now, we'll share the video clip example of our study.
여기 비보호 좌회전인데 굳이 빠르게 갈 필요 없이 진짜 안전할 때 좌회전 해주시면 좋겠어.
네, 알겠습니다.
As in the video clip, there was a passenger and a driver who were our participant pairs on the front seat, and there was a researcher on the back seat. For more immersive AV experience, we implemented a panel between the participants to prevent drivers being seen by passengers. For the study, we recruited 20 participants in their 20s and 30s. The participants were recruited as pairs having true roles, driver and passenger. The passengers became the owner of the AV and had the role of guiding their preferred driving styles. The drivers took the role of an AV agent and drove the vehicle reflecting the passenger's guide. Drivers and passengers had relationships, but had little or no experience in riding together, because their driving style familiarity could affect the passenger's guiding experience. We designed our study process in 5 phases: pre-questionnaires to get basic demographic information, mission cards to give instructions of roles, test driving to get used to study environment, on-the-road driving as the main guiding phase, and post-interviews. Note that all studies proceeded with COVID-19 safety measures, including ventilation, masks, and body temperature check. As a result, a total of 278 guides were made by the passengers. The data was coded and qualitatively analyzed by the two researchers to reach an agreement on the findings from the study. Please refer to our paper for the detailed analysis process. For our findings, we found 3 benefits of driving style guiding: in learning users' genuine driving preferences, in building a sense of controllability, and in forming various human-agent relationships. We'll describe each benefit in more detail. We found that the participants had pre-existing needs in expressing their driving style preferences in road situations. And while the participants were not able to come up with how they want to be driven in the beginning, they could express their preferences once they faced the real road cues. This elaborates the importance of in-situ guidance to learn users' genuine driving preferences. As a result, the driving style guiding benefited users in adjusting the AV's driving behaviors. Second, the majority of passengers perceived more control upon the AV's driving. As the most basic, the driving style guidance enabled users to avoid unwanted road situations, such as following a heavy load trucks. Also, participants wanted to give temporary command that was inconsistent with their driving style guides. For example, while P8 consistently guided to yield to other vehicles for lane change, he did not want to yield to a selfish driver he faced during rush hour. Finally, it is expected to be difficult for an intelligence system to know the cultural or implicit rules of every road. Thus, the situational driving style guidance has a potential in adjusting AV's behavior in accordance with such rules. Third, we found that a few passengers built their own perceived relationships with the agent. The participants used metaphors to describe the AV, such as a role-playing game character that they can raise to make it better, or educational relationships such as instructor-student or father-child relationships. The driving style guidance made a few participants build a sense of unity or a feeling like a friend. Along with the benefits of driving style guidance, we also found the burden of guiding. As the primary purpose of autonomous driving was to relax and focus less on driving, the participants felt an exhaustion from the prolonged focus of guidance. Although many participants agreed that they would actively and repetitively guide the AV in the early stages, they also wanted AV to learn as quickly as possible to gradually lower the frequency of guiding. Also, the sense of controllability made participants feel responsible for the AV's behavior. Their perceived responsibility made the participants concerned about the consequences of their guidance. Lastly, few participants were not confident about expressing their needs through words. They kept in mind that they were guiding the intelligent agent and tried to put their words in their perception of machine-interpretable sentences. In our design implications, we suggest the initial ideas to improve the guiding experience. First, to support self-reflection on users' preferred driving style, to enable users understand how they genuinely want to be driven. Second, to support conversation using questions and suggestions to alleviate burden of guiding in machine-interpretable language and the concern of their guiding consequences. At last, we suggest to deliberately examine the passenger interpretability to understand when the users are willing to share their driving preferences. As a result, we explore the preferred driving style guiding as a novel input channel and reveal the benefits of driving style guidance. Also, we discovered the burden of guidance and suggested main points to consider. We hope that the work inspires both designers and engineers to future study in creating human-centered automated systems. This is the end of our presentation. If you have any questions, we are more than happy to answer them through the email below. Thank you for listening.